In the previous video, we've learned about arrays, learned how to use them and their limitations. We've built the foundation before moving to slices. Since slices are built on top of arrays, it's highly recommended to get familiar with arrays first. You can watch my previous video on the basics of arrays in Go programming language. Unlike arrays, slices are numbered sequences of elements of a variable length. It's like an array but can grow and shrink in size. Similar to arrays, we define slices using square brackets followed by the type, where square brackets do not specify the length. Then, similar to arrays, we can provide the list of elements in the curly braces. If we need to create a slice of a specific length, we can use the built-in function make, which accepts a type, a length, and an optional capacity. The built-in function len returns the length of a slice, and the function cap returns its capacity. We are going to talk about the capacity later in this video. The elements of a slice can be read and set in the same way we read elements of an array. We use square brackets with the element index. On top of that, we can retrieve a range of elements from an array or another slice. Let me define a new slice and show you a couple of examples. To slice a slice, we use the following syntax. In the square brackets, we provide two numbers separated by the colon. The first number stands for a starting index. The second number stands for the last index, but not including it. Back to our example, the first line gets the elements starting from 2 up to 7, because 8 is not included. We can omit those numbers, but the colon has to stay. The missing index indicates the first or the last element. The second line doesn't have the end index, so it slices the initial slice starting from 2 up to the end of the initial slice. The third example prints a new slice starting from the beginning up to 7. Again, it's up to 8 minus 1. The last example returns the whole slice from the beginning till the end. We can use that technique to remove elements from the slice. It removes the first and the last element of a slice. And of course, there is a way to append new elements to a slice using the built-in function append. It accepts a slice as a first argument, followed by the list of elements. Those elements are going to be appended to the slice. The function returns a new slice. Here is the example. The first call to a function appends one element. The second example passes several elements and therefore adds them all to the slice. Now back to capacity. As I already mentioned, slices are built on top of arrays, so a slice needs the underlying array under the hood. That array should have a certain length which remains constant. Slices, on the other hand, can change their length. So the capacity of a slice plays the role of the length of the underlying array, and it cannot be smaller than the length of a slice. When we add new elements to a slice, we are increasing its length. When we reach the capacity limit by adding a new element, Go extends the capacity of the underlying array. Let me demonstrate that on the example. In this example, we start with a slice of 2 elements and the capacity of 2. Then we add a new element to a slice. Since the length of a slice is increasing and we are at capacity limit, Go doubles the capacity of the slice. Now we have a slice with a length of 3 and a capacity of 4. Then we are adding yet another element. There is room for capacity, so the slice gets the length of 4 and the capacity remains the same. When we are adding a new element into the slice again, that changes the length of the slice to 5, which is over the limit of the current capacity, so the capacity doubles up to 8. When we reduce the number of elements in the slice, the capacity doesn't change. I hope that example helps to understand the capacity of a slice. Now let's talk about copying slices. Here is an example. Let's assume we have an initial slice and we need to create another copy of that slice. The first approach can be an assignment of the initial slice to another one. Now let's update our new slice and check the result. We can see that changing the new slice S2 changes the initial S1 slice as well. That has happened because both of our slices are pointing to the same underlying array. To solve that issue, we need to copy elements of the initial slice to a new one. We can do that by using a built-in function copy, which accepts 2 arguments, a destination slice and a source slice. First, we've made a new slice with the length and capacity of the S2 slice. When we've copied the slice S2 to S3, change the last slice and print the result. This time our initial slice remains unchanged. We can also remove elements from the middle of a slice using the copy function. Let's see what is happening here. We defined a slice with 5 elements, and we want to remove the element with an index 2. Then we are copying part of a slice started from the index 3 to another part of a slice started from the index 2. As an intermediate step, we shifted all the elements starting from the index 3 to the left. When we need to reassign a slice without the last element to our original slice. As a result, the new slice has a length of 4 elements. Yet another difference between arrays and slices is that we can compare arrays, but can't compare slices. We can compare slices only against nil. If we need to compare 2 slices, we need to implement that piece of functionality ourselves.